Hello dear students. In our previous class, we had a discussion about sets and representation of sets, types of sets. Plenty we have seen. Now today we are going to solve a few problems, some example problems, and from exercise 1 we are going to discuss a few models. Here we have example number 1 from page number 3. Write the solution set of the equation x square plus x minus 2 is equal to 0 in roster form. As we know that roster form is also called list form. So set can be represented in two ways. One is roster form, another one is set builder form. They asked that the solution set we have to represent in form of roster. What is given here? Equation x square plus x minus 2 is equal to 0. X square plus x minus 2 is equal to 0. We know that it is a quadratic equation. For every quadratic equation, how many solutions we have? Two solutions. So the number of solutions are depending on the degree of the equation. Here x is having the highest power 2, so that we can call it as a quadratic equation. For every quadratic equation we have two solutions, that we have seen in our class 10. Now how to solve this problem? What I am doing here, given equation is x square plus x minus 2 is equal to 0. We go for factorization of this. How to do that factorization? The constant we have minus 2. The factors of 2 1s are 2. If I take minus, so plus into minus, minus 2 1s are 2, and 2 minus 1 gives us 1. That is x square. This plus 1x, I am going to write 2x minus x, and minus 2 is equal to 0. From these two terms, I can take x common, so that I have x plus 2. From these two terms, I can take minus 1 as common, so I have x plus 2 is equal to 0. Again, here I have x plus 2 and here I have x plus 2. So x plus 2 can be taken common. By taking x plus 2, here I have x and here I have minus 1. So x minus 1 is equal to 0. That implies x plus 2 is equal to 0 or x minus 1 is equal to 0. X plus 2 goes that side minus 2, minus 1 goes that side plus 1. Now we got the value of x minus 2 or 1, means these are the solutions of the given equation. So solution set is minus 2 comma 1. So this is nothing but our roster form. This is nothing but our roster form, because we are able to identify the elements, individual elements we are able to observe here. So that this kind of representation is known as roster form or list form. Here we have given quadratic equation, so that we have two solutions. If it is a linear equation, we have only one solution. If it is a cubic equation, you have three solutions. So the number of solutions are depending on the order of the equation or degree of the equation. This is about example number 1. Now example number 2. Write the set x such that, we have to read it as such that x such that x is a positive integer and x square less than 14 in the roster form. Here the question is in which form? We have set builder form. Here they have given a condition, there is a rule. So sets can be represented in two ways. One is roster form, another one is set builder form. Here they have given the question in set builder form. That set builder form can be converted in the form of roster form. Now the set builder form, how we have? There is a condition of that x is a positive integer. What are the positive integers we have? Positive integers are nothing but natural number, means 1, 2, 3, 4, 5 and so on. Here x is nothing but what? Natural numbers. X is nothing but natural number. How many natural numbers we have? Infinite natural numbers we have. But we don't want all infinite natural numbers. There is a condition of that x square less than 14. Suppose x is 1. 1 square is equal to 1 and it is less than 14. X is equal to 2. 2 square 4 less than 14. Like that we have to check. Means the solution what I am taking here, x is such that x is a positive integer. So x may be 1, 2, 3, 4, 5 and so on. When we calculate, for example, let x is equal to 1, x square is equal to 1 square, that is equal to 1, less than 40. X is equal to 2, x square is equal to 2 square, 4, which is less than 40. X is equal to 3, x square is equal to 3 square, 9, less than 40. X is equal to 4, x square is equal to 4 square, 16, less than 40. X is equal to 5, x square, 5 square, 25, less than 40. X is equal to 6, x square is equal to 6 square, 36, less than 40. X is equal to 7, x square is equal to 7 square, 49, is not less than 40. When we take x is equal to 7, what we have? 49, which is which is greater than 40. When we take x is equal to 8, 8 square, 64, is also greater than 40. Like that, from 7 after, every number is not satisfying this condition. Here we have two conditions. The condition number 1, x is a positive integer and x square less than 40. These two conditions has to satisfy. So satisfying these two conditions, what are the numbers we have? 1, 2, 3, 4, 5, 6. So therefore, solution set is, what is our solution set? 1, 2, 3, 4, 5 and 6. So only those are the numbers which satisfy these two conditions. Condition number 1, positive integer. Yes, all these are positive integers. And square of the number is less than 40. So all squares are less than 40. This is about example number 2. Here we have example number 3. That is from page number 4. Write the set A is equal to 1, 4, 9, 16, 25 and so on in set builder form. Now you need to observe the question. What is there in the question? We have set A in which form? In roster form. Here the set is in roster form. That roster form we need to convert into set builder form. Example 2. The question is in set builder form, that we need to convert into roster form. Example number 3. The question is in roster form, that we are converting into set builder form. So, before converting the set builder form, you need to understand the given set and what is the relation between the elements. First, we have a set. In that we have some elements. You need to identify what is the relation between every element of a set. Then only you can write a set builder form. Now let us see how to write it. Solution given that. What is given for us? There is a set A 1, 4, 9, 16, 25 and so on. If you observe, 1 is nothing but 1 square, 4 is nothing but 2 square, 9 is nothing but 3 square, 16 is nothing but 4 square, 25 is nothing but 5 square. Like that, keep on writing. Means, what are the given numbers we have? All these elements are nothing but squares. Whose squares? 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, like that, it will continue. What are these 1, 2, 3, 4, 5? They are natural numbers. So, here the relationship between the elements are squares of the natural numbers. Squares of the natural number. So, that idea we should know. We have to identify that relation. When we know the relation, it is very easy to write. What is the set builder form? Set builder form. A is equal to x such that 1, 2, 3. What are these numbers? Natural numbers. So x belongs to. This is the symbol we read it as belongs to. Means x is a natural number. So x is natural number and x is equal to n square. X is equal to n square. Means that x such that x is equal to, or simply we can write here small n, means n is a number, n belongs to natural number and x is equal to n square. For example, n belongs to, when we take n is equal to 1 is a natural number and x is equal to n square, means x is equal to 1 square. Next, n is equal to 2, x is equal to 2 square, n is equal to 3, x is equal to 3 square. Actually, if you want to write, it is which kind of set? Infinite set. You can't write all the infinite numbers. Simply you can write this condition. So, set A is equal to x such that n belongs to natural number and x is equal to n square. This is about converting the roster form into set builder form. The example 2, roster form we need to find. Further they have given set builder form. So example 2 we have seen how to convert set builder to roster. Now example 3, how to convert roster form into set builder form. This is about example number 3. Here we have example number 4. Write the set 1 by 2, 2 by 3, 3 by 4, 4 by 5 and so on in the set builder form. Here also, when we observe the question, the given set is in list form or roster form. When it is in list form or roster form, we need to convert it in the set builder form. As I told you, when the list form is given, we need to identify the relationship between each element so that you can write set builder very easily. So, let us observe what is given. It is just like example number 3. Given that, let us assume it is set A. What is given here? 1 by 2, 2 by 3, 3 by 4, 4 by 5 and so on. Which is infinite set. Now, you need to observe the relation. What is the relationship between numerator and denominator? When we observe numerator and denominator is 1 more than the numerator. What is numerator here? 1. 2 is 1 plus 1. 2 by 3. 2 by 3. 3 can be written as 2 plus 1. 3 plus 1. 4 plus 1 means the numerator and denominator in such a way we have denominator is 1 more than the numerator. Denominator is 1 more than the numerator. So I can write as 1 by 2, I can write as 1 plus 1, 2 by 2 plus 1, 3 by 3 plus 1, 4 by 4 plus 1, and so on we have. So this can be written in set builder form. Set builder form is A is equal to x such that x is equal to n by n plus 1, where n belongs to natural number. Now x, how you are getting x? X is nothing but n by n plus 1. What is n here? Natural number. What is our first natural number? 1. When we take here 1, we have 1 by 1 plus 1, which is nothing but 1 by 2. Next natural number 2. 2 by 2 plus 1. So 2 by 2 plus 1 is nothing but 2 by 3. Next natural number 3. 3 by 3 plus 1. 3 by 3. Next natural number 4. 4 by 4 plus 1. 4 by 2. Like that, you can keep on writing the numbers. So this is the way the given roster form can be converted into set builder form. To convert it into set builder form, you should know the relation between the elements. Once if you are able to identify the relation between the elements, it is very easy to write in roster in set builder form. This is about example number 4. Here we have example number 5 in another different model. Match each of the set on the left described in the roster form with the same set on the right described in the set builder form. A simple question. Simply they ask us that match. What we need to match? Here we have 2 columns. One is left hand side, we have roster form. On the right hand side, we have set builder form. Left and right. Now, here whatever the sets we have in roster form, the same we have in set builder form also. We have to match the corresponding roster form and corresponding set builder form. We should match it. A simple question. By using example 2, example 3, example 4, we have seen that only. Converting roster into set builder form, set builder into roster form. So, let us see here. What is given? X such that x is a positive integer and is a divisor of 18. Positive integer means natural numbers and divisors of 18. What are the divisors of 18 we have? 1 divides second number, 2 9s are 3 6s. So here the 18 can be written as 1 18s are 18, 2 9s are 18, 3 6s are 18. Now, what are the divisors we have? 1, 2, 3, 6, 9, 18. These are the divisors of 18 and they are nothing but natural number. Now, in left hand side, where we have? Here we have 1, 2, 3, 6, 9, 18. So, these are the positive integers and also divisors of 18. So, this we need to match. Now coming to the second question. X such that x is an integer and x square minus 9 is equal to 0. Here x square minus 9 is equal to 0 is nothing nothing but what? A quadratic equation. We need to solve. For example, x square minus 9 is equal to 0. X square minus 9 goes that side, plus 9. It is square, goes that side, square root. X is equal to square root of 9. Square root of 9 is nothing but plus or minus 3. Means you can take plus 3 or you can take minus 3. Now what is the x values? Plus 3 and minus 3. Where we have? Yes, here I have plus 3 and minus 3. So these two I need to match it. Now coming to the third one. X such that x is an integer and x plus 1 is equal to 1. Here what is the equation has given? X plus 1 is equal to 1 means when x plus 1 is equal to 1, plus 1 goes that side, minus 1. We have x is equal to 1 minus 1, 0. So what is the value of x we have? 0. So where we have 0? Yes, here we have 0. So these two I need to match it. And the last one, x such that x is a letter of the word principal. As I told you, in set, the element should not repeat. Now, what are the elements we have? I have the first letter P. Yes, here I have P. R, here I have R. I, here I have I. N, here I have N. C, here I have C. I, already repeated. Next, T, already repeated. A, here we have. L, here we have. So, P, R, I, N, C, A, L. All these are elements in the word principal. So that these two can be matched. So, this is the way we need to match the corresponding roster forms into the corresponding set builder form. This is about example number 5. Now we have seen 5 examples. 5 are different models: converting into roster form, converting roster into set builder form, converting set builder into roster form, and match the followings. Based on these examples, we have our first exercise. Now let us see the first exercise, how to solve the problems. Here we have exercise 1.1. In this, we have total 6 Romans. Individually, we discuss one Roman. The first Roman, which of the following are sets? Which of the following are sets? Justify your answer. In under first Roman, we have total 9 problems. 9 statements are given. We are discussing 4 statements. The rest 5 you can try. Now the first 4 statements are statement 1. Before discussing this, we need to know the definition of sets. What is sets definition? A collection of well-defined objects. Well-defined means the statement must be universal truth. Wherever you go, you should get the same result. That is nothing but called well-defined. That point should be in your mind. Now, using that concept, we are going to identify whether the given statements are sets or not. The first statement is given: the collection of all the months of a year beginning with the letter J. If that is the question I have given to class 11th students, means for you. Months in a year, how many months we have? 12 months. Wherever you go, you will get the same. In the months which are starting with the letter J, what are they? For this I have January, June and July. Out of 12, we have January, which is a month starts with J. February, March, April, May, June starts with J. July starts with J. August, September, October, November and December. So what are the 3 months which are starting with J? January, June, July. Now tell me, this is the answer I got from your section. If the same question if I go and ask class 10, will I get the same answer or different answer? Definitely I will get the same answer. If the same question is given to class 9, there also I will get the same answer. Class 2nd or class 3rd or class 12, wherever you go, whomever you ask, you will answer it January, June and July. So that, is it a set or not? Yes, which is a set. The given statement is a well-defined, means everywhere you have unique answer. Now coming to the second question. The collection of 10 most talented writers of India. Collection of 10 most talented writers of India. So, here we have a statement that most talented in the sense every individual will have different opinion. If I ask the same question in your class, suppose if I ask for X boy, he will give 10 names. If I ask some other boy, he will give 10 different names. If I ask a girl, she will give again 10 different answers. So, the same question when I have given for 3 students, I am getting 3 different answers. Means, here the statement is depending on every individual. Means, which is not a well defined. So, which is not a set. Now coming to the third one. A team of 11 best cricket batsmen. A team of 11 best cricket batsmen of the world. How can we say? Suppose if you ask the question to me, in my point of view, I can say all our Indian batsmen are the best batsmen I can give. I can give 10 Indian best names. If the same question if I ask some other boy, he may say that no sir, all Australian batsmen are excellent. They are the best in the world. He can give 11 names from the Australian team. Some other boy if I ask, no sir, Asian countries, whatever the cricket teams are there, we are the best. From that I can give some names. Like that, different student will have different opinion about this. Means it is also depending on every individual. Means which is not a well defined. So it is also not a set. Now coming to the last one. The collection of all boys in your class. The collection of all boys in your class. In your class means class 11. So which is a well defined. So the persons means the student will not change. The students will not change. Whoever you ask, they will give the same answer. So which is a well defined. It is also well defined. So the first statement and the last statement, these two statements are well defined, and these two are individuals. So these two are not well defined. These two are well defined. Here they said justify your answer. Justify your answer means we have to write that these two are well defined. These two are not well defined. This is your justification. We have 12 months. Out of 12 months, only 3 months we have starting letter with J. Here list of boys. You have few boys are there. You can list out their names. That is well defined objects. Here these two are not well defined. These two are depending on every individual. So this is the Roman 1. We have 4 problems. Still remember 5 more problems are there. Those you can try it. Now question number 2. Let A is equal to 1, 2, 3, 4, 5, 6. Insert the appropriate symbol. This is the two different symbols we have. This symbol, this is, we can call it as belongs to, and this symbol we can call does not belongs to, does not belongs to. What is the meaning of belongs to and does not belongs to? That we are going to check it here. What is the given set we have? Yes, we have a set A, and set A is a finite set, and which is in its form? Roster form, because we are able to see the elements. How many elements are there? 1, 2, 3, 4, 5, 6 elements are there. What are the elements? 1, 2, 3, 4, 5, 6. Here I have 6 blanks. I need to write that in each blank the appropriate symbol, whether I need to write belongs to symbol or does not belongs to symbol. How can we write it? That we can observe. First blank, 5-A. Here 5, this is nothing but called element. Here A is nothing but called set. Now 5 is there in set A or not? We have to observe that element 5 is in set A or not. Observe here set A. Do we have 5 element or not? Yes, we have element 5. So we can write here belongs to. So 5 belongs to A means 5 is an element in the set A. That is the meaning of belongs to. Now the second question. 8-A. 8 is an element. Whether this element is there in set A or not. See here. Do you have 8 here? No, we don't have 8. Means 8 does not belong to A. 0. 0-A. Do you have 0 in the set A? No, we don't have. So again 0 does not belongs to A. Now 4-A. Do you have 4 in the set A? Yes, we have 4 is in set A. So I can write here 4 belongs to. Now 2-A. Do you have 2 here? Yes, we have. So 2 belongs to. 10. Do you have 10 in this set A? No. So what we write? Does not belongs to. So here left hand side we have all elements, right hand side we have all sets. So whether the element 4 is in set A or not. If it is there, we have to write belongs to. If it is not there, we have to write does not belongs to. This is our problem number 2.